I'm Terry Moore. I'm the CEO of MCCI Corporation. We are a system software company. We're based in New York. We've been around for 28 years or so now. So we do a lot more than IoT. We didn't really start as an IoT business. We have been doing embedded software and industrial controls for a large part of our history. So there's a connection to IoT, to be sure. So I wanted to talk about how we approach this and how what we have found to be successful in doing IoT projects. So it's really pretty simple. And part of it is, a lot of this has been talked about in the previous talks. Oliver was talking about keeping things simple and dealing with the decision complexity and this kind of stuff. What we try to do in IoT is work with subject matter experts. These are the people who understand the process that they're trying to control or automate. I'm using process in a very generic term. We find out what they want to do, and we figure out what they already know how to do, and we fill in the rest. That's our job. So it's basically, we are not, as IoT practitioners, we are not trying to push our solution on anybody. We don't have a solution. We have a methodology. And we use open source. Almost all of the software that we produce for this, as long as the customers don't have key IP, is open source. We build on standards, as people have said, because the big problem in IoT is not any one of the components. There's not a lot of value in any one IoT component. The value comes from getting the data from the field to the eyeballs, so that the people who want the data get the value and will pay you for doing this work, and pay the subject matter expert and validate the work that's been done to do the investment. So this says that you really focus on implementation before generalization. You do want to generalize. You want to be able to have economies of scale. You don't want to do the same darned thing over and over, but you resist the temptation to invent before finding the actual practical use cases. So I'm going to talk about a few of our use cases here. The first one I've listed them here, but I'll just go through the slides. Maybe. Yep, there we go. So the first application I'm going to talk about is we worked with a startup. This was a subject matter expert who knew a lot about compost. You may be aware that compost is generated primarily as food waste, also as agricultural waste. There's a lot of it. Particularly in a city like New York, there's a lot of waste. There are a lot of trucks that roll to move that waste from the restaurants to the dumps. And so you can really make a big difference if you can encourage composting, because it makes instead of it being dumped waste, it becomes recyclable material. You reduce CO2, you reduce the volume, it's all good. So we Radiate, which the link there, they've created a protocol for dealing with the particular practical problems of composting. There are lots of problems. There's an economic benefit for this. The key economic benefit is that if you can demonstrate that the compost has been above, I think, 131 degrees for 11 days, that you get a lot more money for that compost when you're done turning it into compost. And there's also regulatory compliance things. If you want to reuse the compost, depending on the state, you have to file reports to say that you've actually done your work. This is a very labor-intensive process. This is what Stephen was talking about, with people walking around with a thermometer on a stick, poking it into the compost pile, and then writing down the data, and then rekeying it, making reports and doing it differently. So there's a big opportunity as a business for We Radiate to help the compost people manage things. So they knew compost in and out. They are not IT people. That's our job. They were not embedded system people. That's our job. They did know how to design the thing that plugs in, that pokes into the compost, because that's actually a very nasty environment. It's a reactive, highly reactive environment. It eats things. So we designed the electronics, and we helped them fabricate the electronics. We designed the back end. You'll recognize Grafana, of course. We use the classic pipeline of Influx and Grafana, and we use the Things Network for this because in their process, they're just now getting to the point where they need an SLA. So the Things Network was perfect for the few hundred devices where people have to get success before an SLA is economically relevant. So we also help them because of the reporting things. Their customers know Excel. Their customers know G Suite. So we help them with designing the plugins for Excel and the Google Docs to make their reports directly from the database. So, and that's in parallel to all of the real-time reporting. So this has been a very, we're very happy about this customer. They won a New York State Innovation Prize, which contributed to their funding. So it's been a very exciting thing for them, and this remote sensing is a key part of their business model. So completely different. We got involved in New York City with high performance buildings through people who were involved in the Passive House community. Passive House is a European standard for creating buildings. If you comply with the standard, you should have buildings that for a period of time are net zero resource use, possibly net positive resource use. This is not really caught on that much in the U.S. because of primarily because of the complexities of regulatory compliance in the U.S. But New York City, where we have a big presence, is a big center of passive house design for the United States. There are a lot of passive house buildings. And so we got involved, and we had a subject matter expert in passive house who said, we have a problem. We've built these buildings, but we don't know how they perform over time because they're complicated machines and they're going to age. How do they perform? And the other question is, in the climate of the United States, how do the passive house standards do? Because those standards were designed for Northern Europe. So we built a number of sensors for them, including this power meter, so that they could measure the power coming from the grid, the power they were selling to the grid from the solar panels. And we made it. One of the things about passive houses is that they're small. And so they pushed us. Look, we had put something together with off-the-shelf stuff, and they said, look, this is too big for residential installation because a typical passive house is 1,200 square feet. And so your utility closet is very small. You got to fit this inside the panel. So we worked with partners. We figured out how to do this, and we did some successful installations. And suddenly we are getting approached by people with much bigger use cases who need this as a component of a bigger system. So and once again, in this, for example, we're working with a big box retailer. They have a problem with the forklifts. That's the graphic. The forklift chargers in the distribution systems use a lot of power. They use it's the amperage is typically 4,000 amps, and the voltage is typically 480 volts. So it turns out that the power quality is really important to them, because if the utilities are not selling them good power, you can blow things up, and they were blowing things up, and so that justified installing a few hundreds of these meters at the various distribution centers, and they're monitoring stuff. But again, we had to work with them because the big box retailer doesn't actually do any of the electrical installs themselves. They have a national contractor who does all of the design work for the installs, deals with the things like the fact that there's something called arc flash restrictions. It's a very important safety thing in the power industry. And then they work with subcontractors to install things. So you see a meter like this, they have to shut down the distribution center to install it because of the arc flash regulations. And then it's retrofit, which means it's going to be wired by hand, which means there are going to be mistakes. And so the only way you find the mistakes is to turn on the building, look at the data, and then if there's something wrong, fix that. So we realized, just from that description of the problem, and from the fact that the people doing the install don't have access to the data. So we built an Android tablet and an application that connects to these things in the field via USB, because we're USB people, and lets the installer look directly at what's going on without having to be connected to the big box network, and to do certain corrections to the wiring without even having to turn off the building. So if the wires are reversed on the CTs, or many of these things can just be fixed in software, so they can just do that. They can confirm the data is right. We can use off-the-shelf screen sharing software so that the national contractor can look at the data right away, or if necessary, call in one of our engineers to look over their shoulder. It's been a very, very smooth rollout for people who had never done any of this stuff before. The biggest problem that we're finding right now is that tracking where things are it suddenly becomes a very big problem, because people move things around, they don't read the labels, things get shipped the wrong place. So we're working through that kind of stuff. Long term, GPS is not necessarily a good solution for this, because you're inside a panel, inside a building, you have no reception. So it's going to be an interesting problem to really figure this out. You can use the gateway localization kind of stuff to help, but there are some unsolved problems. But the key thing, again, we worked with the subject matter experts. We asked them what they needed. We figured out what success was, and we worked backwards to get the requirements. We didn't come in with a platform and try to map their requirements onto an existing platform. We created the software to match their requirements using components that were smaller. We saved them from the decision fatigue of having to even approve and review the components we're choosing. We just said, here it is, we'll figure it out. And that's really important, because people in large organizations have to be given very simple, a very simple, clear description of what it is that they're buying, and not be drowned in detail. So the third application that I'm going to talk about is very similar to the first one, in that it's a startup, but it's a different kind of startup. We worked with a neurophysiologist at Washington University, St. Louis, in the medical department, who does research with mice. He studies how drugs affect the activity of the mice and affect the circadian rhythm. He's a tinkerer, and so he was able himself to use an Arduino and come up with a way to measure the activity of the mice. And he'd published a bunch of stuff and open sourced it, but he didn't have he had tried to use Wi-Fi to the backhaul. Wi-Fi doesn't work very well in this use case, because you have a very high density of devices, and the typical gateways don't seem to work. And he used a couple of other approaches. He came to us because he saw we were doing open source stuff. I run the Things Network New York, and so he found us through that activity and said, hey, look, we've got this stuff. So we helped him connect his sensors to LoRaWAN. Again, we helped him do the production of the devices. We did all the back-end stuff for him. He's a much more technically oriented person than the people in the compost area, because the compost people are much more focused on the agricultural side, whereas he's very keenly interested in the data. But again, we just sort of filled in the gaps and helped him do what needs to be done. He's turned this into a business, which is now ramping up and helping monitor mice in cages. It turns out that this could be a very big business because monitoring mice in cages is very labor intensive. It's, again, the same kind of thing of people walking around and looking at cages. There is a bunch of data reporting in the bigger applications that he's looking at, but there's also a lot of animal care that has to be delivered. You have to, if you've got 200 mice in a typical lab, 200 cages, you have to clean those cages regularly. And the way they know to clean those cages right now is they look at the calendar. It's Tuesday, we clean the cages. And you have to go observe every mouse in every cage and say, is this mouse well or not? And the activity detector tells you that right away. It's very clear. So our role is basically a role of a facilitator. I majored in philosophy, and so I can't ever do a talk without putting in some philosophy reference. Thomas Aquinas used to say, or he wrote, that philosophy is the handmaiden of theology. He meant, to do theology, you got to use the tools of philosophy. Well, to do, it's the same kind of thing. To do this kind of service, you got to use the tools of embedded system development, the system software kinds of computer science things. But that's not the goal. Once it's done, nobody's interested in how you do it unless you did it wrong. So in all of these cases, and we have several others. We're doing some work with agriculture in maple sugar bushes. Maple sugar bushes spend a lot of money on optimizing their production because it's a high value product. So various other things, but it's lunchtime, and I don't want to go on beyond my welcome any further beyond my welcome than I already have. So if you have any questions, I'll be around finding something to eat. Come find me, and I'll be happy to talk to you about what we do.